I think you people are doing many projects using sensors. There are so many sensors, you know. So like proximate sensors, ultrasonic sensors. Just a minute, my screen is not moving. Is my screen is moving? Is anyone confirm?
Yes, ma'am, it's moving, ma'am.
Yeah, thank you. So these are all some sensors. So these sensors are made of materials. So you all know the importance and significance of the sensors and the materials behind. So that only we are going to discuss today. So, and one more questions I'm just putting to you. So what difficulties you are facing while choosing the sensor materials? Because some people are doing some projects. Most of the students are from second year and third year. You're doing some projects, I know that. So can you tell me some difficulties while choosing some sensors materials so that I can start with that? I just want some answers from the chat box. Yes. So what difficulties you are facing while choosing some sensor material? For example, if you're choosing some ultrasonic sensors, okay, is that sensor material is more efficiency in all the time? Or loading sensors or IR sensors? Because so can you mention what sensors you are using for your projects? Any sensors in the chat box? I just want to see. No one? Is there any sensors are you using for your applications? You can post it. Because my topic lies on this area only. That is why I just want to get some idea about, do you have any idea about the sensor materials? My answer is, question is clear to you? No sensors materials? Yes, plain sensors. Okay, THC, ultrasonic. Okay, fine, very good answers. What difficulties you are facing? Is a sensor material is more efficient for all the time? Sometimes the sensor materials may be quite efficiency while doing pilot test. When you're going for the bulk, so that may not be efficiency. The output will not be, you may not get the exact result what you expected. Am I right? Yes or no? Are you agreeing with my point? Thank you. Okay, so with that, I'll just move on to the next part of my presentation. So actually today we are going to deep about the material synthesis. Okay. Whether it may be a natural or whether it may be a natural or synthetic. Okay. There are many sensors. We can also synthesize using natural materials, and synthetically also we can synthesize. Okay. So this is my overview of my talk. So I'm going to talk about the synthesis of organic material, what I synthesized, and the characterization and the crystallographic studies and applications. So particularly the optical communications and pharmaceuticals, because most of your applications based on the optical communications. Okay, fine. So the materials, particularly if you take a sensors, so the materials where it is applied, it is used as a sensors and also used in lighting displays and new materials for batteries. So for example, lithium nowadays we are using, and in future they are going to use sodium as a the battery materials, and not only that, in medicinal fields and electronics, photonics, and also in the corrosions preventions, the materials plays a vital roles. Okay, so and these are all some applications of the sensors in the autopilot system in aircrafts. And in medicines, if you take drug dosing equipment, they are using sensors, hospital beds and hospital gas supplies, so etc. etc. Because you're all aware about all those things, I just want to have a glance to look over. That is why I just prepared the slides. Fine. So next, how these sensor materials are prepared. That is very important because the material is plays a vital role in everyday life, and it impacts on future technological process. And particularly if you're going for the functional materials, the ability to confine the properties, to control the location, that is the structural location is very, very important. So while doing manufacturing, what happens, they particularly go for the confining structure. So that is very important. So how this is synthesized? So when you go for an experimental method, so they can synthesize from bulk materials to atomic levels, or they can go from atomic levels to bulk materials. So when bulk materials to atomic size, it is called as a top-down process, whereas atomic level to bulk materials is called as a bottom-up process. This I think you are aware about in nanosynthesis. So the bulk material converted into atomic size is called as a top-down process. Top means a bulk, and down we are converting into atomic size. And these are the methods, especially what are very specific methods by which the bulk materials can be converted, drop down to atomic size. That is called chemical etching, laser ablations, lithography, thermal decompositions. And similarly, the atomic size also converted into bulk materials by the methods of vapor deposition methods, salt gel methods, spray methods, molecular condensation, aerosol process. These are all some process, and mostly these are all green synthesis method also. So nowadays we are all moving towards an eco-friendly procedure. So most of the scientists, they are going for this process. And here I have shown how the materials are synthesized. This is an experimental material. Just to have a glance, I've just displayed this. And the sensor materials in the medicines, how it is applied, and how these materials plays a vital role in the field of medicines. That is the slide talks. And here you can see some cancer cells are identified by using some fluorescent sensors, fluorescent sensor materials. So using the fluorescent material, the cancer cells are identified using a gold as a nanoparticle. So, and this is again one more chemosensors. Different metal ions, when it is placed in this chemosensors, it is helps to identify the infected cells. So particularly, for example, in the kidney, some stones may be there, or some cells, tumor cells may be there in the brain or in other organs. So particular, the metal ions able to identify the infected cells, and also it can able to cure it also. So all these slides I just talked to stress how the sensor materials plays a vital role in all the fields. So here are some sensor materials I have displayed for your reference. So both organic as well as inorganic sensor materials I have displayed. Okay, so now we move on to my research area of specialization. So I have prepared some materials, which is a functional material, I can say, both having application in optical communications as well as in medical applications. So actually, I just want to share about some what interesting facts happened during my growth of crystals also. So during my research, some interesting facts, unexpected facts happened. That also I just want to share it so that you can know how the what the structure. The structure is very important in selecting the sensor. Okay. So I have chosen my compound as alpha hydroxy ketone. So alpha hydroxy ketone, I'll show you what is the structure, then you can understand. So that is a basic functional group of my research area. And I synthesized that alpha hydroxy ketone, and I analyzed that, and I have studied the optical properties and also the solvent effect of my all the crystals, and also I studied about the thermal analysis, and finally I proved how it is more efficient. Okay. So this is my overall talk about my research area of specialization. So why I chosen this alpha hydroxy ketone as my compound? Because it is having my compound is very biologically active, and it is having a very good NLO properties. NLO properties nothing but non-linear optical properties, Actually, this property plays a vital role for the communication, telecommunications and optical communication industries. And my compound used for preparing many starting material, and it is having a very good fluorescent property. And one more property is very, very important, hydrogen bonding. You may think that is these topics are very new to you, but this, if you understand the property of this material, then only you can come to know how your material playing a that is how the efficiency of your material is very, very important for finding what applications in your projects. Okay, that is my okay. So here I prepared 5 crystals. So out of 5 crystals having different properties. Okay, so even though the core structure seems to be same. So you see my slide. So here the CHOH CO group is here. This is called as an alpha hydroxy group. I told about the alpha hydroxy functional group in the slide, right? So this is the alpha hydroxy path, CHOH CO group. Okay, this is the core structure. I took this core structure and then for my analyze, and I introduced many substituents. So substituent in the sense, so either here or here or here I introduced substituent. Same substituents are different substituents. So when I'm introducing the substituents to this core structure, the functions of the material drastically varies. That is my point. Okay. So even though the core structure is same, when I started introducing some methoxy group, see here, methoxy group, at ortho position. You may find difficulty in understanding what is ortho position. Just recollect, you will understand because you know what is ortho position. So this is ortho position where I'm keeping my that is pointer. So when I introduce my methoxy group here, because of the substituent, this compound changes the property entirely. When I started introducing another group that is called fluoro group at para position, so what happened? The property entirely changed. This is para position and this one is an ortho position. Okay, this is ortho position and this is para position. Okay, so see the core structure is same, but yes. And shall I continue?
Yes, ma'am.
Okay. So that is my key point of my talk. Okay. So, okay, fine. So now what I just talk about how this compound is prepared. I took benzaldehyde, I added catalyst. So this compound benzoin is prepared. So this benzoin compound, I have introduced the methoxy group here. So by adding 4-methoxy benzoin. So what happened in the previous case, I had only benzoin. Now, next step, I introduced 1-methoxy group here. And one more compound also I prepared. So by introducing fluoro group in the that is a ortho position. So this is another compound. And what I did is I took this compound as a starting material. I introduced instead of the CO group, I have changed my structure as NNHCONH2. Please watch my pointer, then only you can able to understand. Otherwise, okay. So what are the compounds I prepared? I took this co-structure. I introduced one methoxy group here. Another compound I introduced one more fluorine group. In another compound I introduced another derivative group, that is NHCONH2. So then after that I analyze the property. So what I found, even this co-structure that is alpha hydroxyketone group, when I introduced one substituent, according to the nature of the substituent, the property of the material changes. That only I analyzed. Okay, and this is just very surprising thing I got it in my research. So what I did is I introduced one more chloride instead of CH3 group. I introduced one more chlorine group in this compound. What I expected benzoin, but I didn't get that benzoin, but I got benzyl. That is this CHOH CO group is totally converted into C double bond O, C double bond O. Actually, this compound will be getting only after oxidation. That is, by adding some nitric acid or sulfuric acid only, I can get this product. But instead of adding any oxidizing agent, I directly get this product. So I was surprised to see that why this has happened. So because of these two chlorine group, some steric hindrance happen, and that is why the compound is completely converted into CO group because of aerial oxidation. This is a very surprising thing I got it from my research. Okay. So why I am stressing all these points? Because these substance only we are going to use as a sensor material for your applications. Okay. So this substance is going to play a vital role for the efficiency or for the other things. Okay. That is why I'm stressing all these points. Okay. So only the substance are playing a very, very important role in your applications. Okay. So what I did after that, I just go for the studies. So these are the crystals. See, when I synthesized, I'll do for crystallization. Why I'm doing crystallization? If I started growing crystal, when I take this compound and then I started recrystallization. So what is recrystallization? By adding some solvent, suitable solvent. So when I added suitable solvent, the substance started crystallizing. So these are the crystals I got it from my research. So these crystals plays a very important role in the physioelectric properties. You know all about the physioelectric properties. Actually, the crystals plays a very, very important role for the physioelectric properties because there should not be any defect in the developing the crystal. If there is any defect, what happens? The property destroys. Okay. So then when you're using this crystals for your communication purpose, optical communication, laser technology, what happen? Then your material will not function very nicely. That is why the crystal defect is very keenly managed. So we have to grow the crystals very carefully. Then only we can get the crystals without any defect. Then only you can able to get a very good property of that can be used for the optical properties. Okay. So these are the very crystals I got it. See, you can see very, very big crystals. This is possible to grow. Particularly when you are mixing some inorganic substances, you can grow very, very, very big crystals like this. And these crystals find a very important properties in all the optical communications. So whatever applications, optical communications, or in laser technology, whatever material you are using, they are all these kinds of crystals. Okay, those crystals may be in organic substances or maybe in inorganic substances, but I used only organic substances because it is having some specific reason that also I'll explain. Okay, so any doubt so far? Please, you can post it in the chat box so that I can able to continue. Any doubts, or are you able to understand what I'm trying to say? So no answers. Why so silent? Say yes or no. Is there any doubt? Shall I continue? Okay, fine. So I take your silence as a confirmation. Okay, fine. So now, so what happened? I undergo single crystal XRD studies. So using that studies, I able to find this is my structure. See, before this, so this is my structure. This is my structure. So inside this compound, how the structure is arranged. So you are able to get the structure only by XRD studies. Okay. So when you grow crystals only, we can able to get this kind of structural representation. Okay. So I did all single XRD studies for all my compounds. You can see each and every crystal, they what crystallizes with different space groups. I know I think you all know about the space group because you have studied in the physics. Okay, so different space groups. So space groups here, this crystal with B1 crystal monoclinic structure, and this is with a triclinic structure, and this is with orthorhombic structure, and this is also again with the monoclinic structure. So I just want to confirm my compound with this IR studies. So this is in spectra, IR spectra, infrared spectra to confirm my compound. So see, this is my structure. So I just want to confirm my compound whether the functional groups are present. So I got a peak around 3369, which says there is no OH group. And similarly, C4 group at 1715 that shows my compound is 4-methoxybenzoin. And similarly for methoxy group, I got one more peak. Similarly, I tried for other compounds also. So all these spectra confirm my compound is formed. Okay. And further, I went for the solvent studies. So why I do solvent studies? Because the solvent interaction plays a vitally important role again in the optical communications. Okay. So when you're using these kinds of crystals in the optical communications, sometimes what happens, the polarity of the environment varies. What happened? The informations what you're getting also, there may be some distractions in the communications. So for that, we are doing some solvent effect studies also. So I took different solvent and then I studied with my compound. So these are the studies I did for various solvent like ethanol item, acetonitrile and chloroform. Why this different solvent means because this ethanol is highly polar solvent. Acetonitrile is it is non-polar, but it is what it is having somewhat little bit polarity. Chloroform it is completely not. So that I took different solvents with a different polarity nature and study. So this is a fluorescence study. Why I did this study is because when you are using these compounds for the optical communications, the excitations plays a vital role. So when you took some spectral studies, I found the electrons which is in the ground state is more in the less polar solvent. When I go for the polar solvent, the electrons are in the excited state. So that means excitation is more in the polar solvent. So when you're using this compound in a highly polar solvent conditions, the excitations will be more. Then optical communication receiving messages will also be more. So for that, only I did this study. So I'm not going deep into this because it is completely chemistry part. I'm just giving some glimpse how this materials are helpful in all your applications. That is it. Okay. So similarly, I did for IR spectra and UV spectra. All I'm just skipping because I don't want to go in more deep into this. Okay. And so this is again very important for optical properties. So I did an NLO studies. So during my crystallization of the crystals, I found some of the crystals having a non-centrosymmetric crystal nature. Actually, non-centrosymmetric crystals, if suppose the crystals are crystallized in non-centrosymmetric crystal nature, though they possesses very high optical properties. So for that, I found the 4-methoxybenzoin, that is the compound which is having a methoxy group at ortho position, found to be more non-centrosymmetric, and they have an efficiency of 100 millivolts than that of the standard KDP. Standard KDP in the sense potassium phosphate. Okay. So when I compare to the standard, my compound having 100 times more efficiency than the standard. Whereas the other crystals, it is not with the central, it is not with the non-centrosymmetric. They found to be crystallizes with the centrosymmetric. So I already told, even though the core structure is same, because of the substituent, the properties varies. So that you can easily find it from here, this compound. See here, this is only methoxy group here present. So when the methoxy group is present, the efficiency is 100 times that of the standard KDP. Whereas when I introduce one chloro group in this opposite direction, see, this is methoxy group and this is chloro group. So can you see this one? So when I introduce one chloro group, the property completely changed. Now this crystal is non-central, it is centrosymmetric, whereas this crystal is non-centrosymmetric. So that is why the crystal nature differs and the properties also differ, very much differ. Okay, and also analyzed with other compounds like that is for that nitrogen containing groups. So they also possesses a different property. So from that one day, I just started confirming that the substituents and the functional groups plays a quite important role in the functional materials. Okay, so that is this is the studies about that. So I studied Hertzberry method study for this one, and here Z-scan studies for this compound. Z-scan studies for centrosymmetric crystals, whereas Hertzberry method studies for the non-centrosymmetric crystals. So from this I confirm this is more efficiency than this compound. So this materials can plays a vitally important role in all the optical communications, laser technology, and in many fields. So why this is more efficient, that I want to tell here because of the substrate. This methoxy group is acting as an electron donors. So what happened? This methoxy group gives, that is, pushes all the electron to this benzene. Whereas here, methoxy group is also present and fluorine group is also present. So this methoxy groups donates electron to this benzene ring, whereas this fluorine groups pulls electron from the benzene. So as a result, the crystal is centrosymmetric, whereas this crystal is non-centrosymmetric. That is why this is more efficiency than this crystal. Are you able to getting my point? See, just by introducing one fluorine group in the that is in the ortho position makes completely the property of the crystals different. Okay, see the efficiency. This is 100 times, whereas this crystal no efficiency at all. That is why I did for the Z-scan studies, and they can be used, but not that much efficiency. This is only because of the substituent. Because the substituent donates electron, whereas this substituent pulls electron. That is why this difference. Understand? So that is why your materials varies when you are using for many applications. Even though the sensors, you may tell this is an ultrasonic sensors, maybe used for this purpose, proximate sensors for loading purpose, like that. You have an idea about the sensors, but while going for an efficiency study, they differ. That is because of the material characteristics. Okay. So, and next we also study an ultrasonic studies that I don't want to discuss here because this is the more chemistry area. I just move on to the next part, which is the thermal analysis. Because thermal analysis, why I just want to tell, because most of the students, people are working on medicinal fields also. So that is why I just want to tell about this thermal analysis here. Actually, why usually we do thermal analysis test for the synthesized crystals, because we have to that is test whether the material is very stable or not. For the drug synthesis, the material should be highly stable, because I mentioned because the sensor materials are widely used in medicinal fields. So in that case, if you're using these kinds of substances, they should be highly stable. Otherwise, when it easily decomposes. So these are the studies I have did for all my compounds, and also I confirmed the property varies according to the crystal natures, the substrate natures. Okay? And I studied what medicinal studies, like in vivo studies will tell in biology. Using rats and mice, I have administered my substances to the rats and mice, and then I found the compounds having different activity based on the structure. Okay? So The compound which is having only methoxy group, they are highly anti-inflammatory. The compound which is having fluorine as well as methoxy group are very potential towards antidepressant. And the compound which is having that NH group, they having anti-convulsant property. And one more compound I synthesized, I discussed, right? That is that having two chlorine group. They possesses what antifungal activity. See, I already told the structure is same. The core structure is same. Only the substituents they are playing very vital. See, even though core structure is same, this compound having antidepressant, and whereas this compound having what convalescent property, and the 4-methoxybenzoate group having anti-inflammatory activity. So see the difference. And also we studied the tissue culture studies. So see the antidepressant drug. When I tested with the tissues of brain cells, they having very curable. It is proved it able to cure the inactive cells. And similarly, the compound which is having anti-inflammatory activity, we tested with the lungs. So I found the potential. I started finding the improvement in the cells. Similarly, the antidepressant activity, anticonvulsant activity, all activities we did this microbiological test. So this is called as an the microbiological test, we can say. So when I administered the drug which I synthesized to the rats or mice which is infected, and I tested with the tissues, I found very good activities. So this also proves the course that is the substituents and the function which plays a vitally important role for all these differences in the activities. These are my studies. So this is a graphical move. I compared with my standard. Usually we compared with our standard, and I took different dosages: 5 ml, 15 mg per ml, 10 mg per ml, like that. So the activity differs because in the medicinal field, the dosage is very important. So different dosages we have tested with the test animals. We found the activity potential, and also we fix the dosage according to that. So where when it reaches to the toxic levels, we stop and then we'll confirm. So between these two concentration, the activity is more like that will confirm. Similarly, this is a tissues test I told already, and this is called an what agar-agar test. You can say for growing. We culture this microbiological test. So the compounds able to reduce the that is, it is acting as an antimicrobial activity. So this is one test we did. So from all these things, we just come to conclusion that is only the substituents plays a vitally important role. Whether it is an optical there is a property or in the medicinal fields, the substituents and the functional groups plays a very important activity. So that is why these materials are proven to be for optical communications and also with the medicine. So I just want to confirm that is you can also you can purchase many materials from the markets. So while choosing the materials, just have an idea what is the background of the material and what is the function of the material and what is the substance of the material. Have a glance of the material, and using all these knowledges, you can apply in your applications. Then you can find a very good efficiency of your project. This is what I want to conclude here. So if you have any doubts, you can ask me, because I didn't go very deeper. I just my idea is I just want to trigger you about the material backgrounds, because you people are in engineering streams. You are definitely know that for the technological development, materials are very important, particularly the sensors. Okay, so when you're choosing any materials for your applications, you should definitely you must have a knowledge about the what is a functional area. So if you have any queries, you can ask. With that, I'll stop. Yes. Aditi? Yes. So software used to analyze the crystal structure and property. Yes, we have softwares. We have a software Gaussian softwares. Actually before nowadays there is before synthesizing. What we are doing is we are just giving the structure as an input in the software. From the software, we are able to be able to collect whether the material is very suitable for the particular application. For example, if my material, I want to prepare a material which is very suitable for the optical communication, then I use the software and then I give the input, whatever that is predicted structure in the software, and for using from the software, I get all the outputs about the structure. So that is a Gaussian software we are using. That is called computational studies, DFT studies, we can say. Okay, DFT studies. That is we are also simultaneously doing some project, that is some work based on this softwares. DFT studies we are doing. Any other questions? Are you able to get it, Nazia? Any other questions?
Students and dear participants, if you're having any doubt, you can ask ma'am. Just you can post it in chat session.
So is that sufficient, or you want to have any some more ideas? Because it is very vast area. I'm just giving only just vision. That's all. Because when when I discussing with the there is engineering staff faculties, I come to know there is our materials, there is the synthesized materials that they are using. So in that I just want to have some discussion how these materials are prepared, and then you can approach us for the materials also. It is very easy for us to synthesize these materials and also give the proper characterization of these materials. Everything we can give you, and when you are applying this in your that is it is very easy to apply also, because the compound can be used as a thin films or as a crystals, or just a smearing part. Or there is even if you smear on your object, the efficiency you can see. Even you can approach me if you want to develop some applications. You can come and approach us. Definitely, we are here to help you. Actually, I'm working only on the organic part, and even inorganic materials can also be. They are also having very good application. Actually, why organic materials I chosen? Because the benzenes, you know well, it is the electrons are delocalizing. So that delocalization helps to improve the efficiency of the material. That is why I choose the organic materials. Even semi-organic materials can also be used. That is organic as well as some inorganic dopant like zinc, cadmium, copper. Some metal ions we can introduce into the organic materials, so that also improves. I did one salt cone studies, so the efficiency is very much increased. I found that, so that is also ongoing progress and ongoing project. So if you want to have some idea about the materials, you please approach us. Definitely, we are here to help. Any other questions? What is your feedback? Are you able to get some idea? Okay, ma'am, I think I don't have any question. It's not here. Thank you for the opportunity. Thank you, team. Thank you, ma'am. Thank you, ma'am, and all the coordinators and team.
Thank you so much, ma'am, for your idea.
I don't know how far
Thank-
my topic was it fully chemistry.
Lakshmi ma'am, can I
We
go
came
with
to
the
know
vote of
about, ma'am.
Yes, ma'am.
We came to know about these things, ma'am.
Materials that's new for the students, ma'am.
Yes, yes,
Is
ma'am.
so far they might not have any received any idea about those materials and how materials plays an important role in sensor and all. So by listening to your webinar, that knowledge may be instilled in the mind of the students now.
Actually, that is why I chose this topic, because I just want to
They
show
know
you
about
how.
sensors, but they don't know what is the role of the material inside the sensor.
Yes, that is why I chose this, because I'm approaching, like many students are approaching me for some basic ideas about the sensors. So that I have an that is the main aim of this webinar also. So whenever possible, that is depending upon the students, that is base skills and knowledge, I will give you some more inputs also, because this is vast area. So I don't want to go deeper into this. I just show all whatever basic things I did. Thank you. Thank you so much.
Lakshmi ma'am.
Thank you, ma'am. Suvantani, you can
Yes, ma'am.
continue, ma'am. Yes.
Thank you, ma'am. It is such an honor such honor for me to get the opportunity to propose a vote of thanks on this memorable occasion. First of all, my sincere thanks to Almighty God for making today's occasion a grand success. I extend my gratitude to our honorable chief guest, Dr. B. Thanuja, Associate Professor, Department of Chemistry, C. Sairam Engineering College, to take out time from a busy schedule to grace the event. Thank you, ma'am. And I express very heartfelt thanks to our CEO, Sir, Sri Sai Prakash Muthu, and our Principal, Dr. K. Purkumaran, our HOD Dean Academics, Dr. J. Raja, for the valuable support towards this occasion. A special thanks to our IEEE Captain and IEEE SB Counselor, Dr. S. Brinda Ma'am, and Lakshmi Ji, Com Society Chapter Advisor, to make this event successful. I must thank the organizing team volunteers for working hard for the past few days to making this event successful. Last but not least, thank you everyone once again for making this event a great success. Thank you, ma'am. Thank you, Ramya ma'am.
Thank you, thank you. Ma'am, shall we wind the meeting? Thanuja ma'am
Yes,
have
ma'am.
left it.
Yes, ma'am. Thank you, participants.
Thank you, students.
Adi, we can wind up the meeting, Adi. Just close the meeting.
Yeah.